Good afternoon, good evening, good night to all the people who are here. But my name is Shardul Kazi. I am from Toshiba. I wanted to tell you about our engagement on this program. We have been engaged in this program for more than a year now. And as you heard in the previous sessions, Toshiba has developed bridge ICs and switch ICs. We developed these ICs because we wanted module developers to use these chips so that they don't have to go into nitty-gritty of Unipro IP and protocols and networking and all those type of things. But today, I'm going to talk about module reference designs because we wanted to bring the barrier to entry for module developers even lower. After developing bridge ICs, module developers are going to use these bridge ICs and connect their technology or their ASICs with those bridge ICs. And how do we make it work? Those are the questions. So what we did was we have a lot of our own technologies. We took some of the technologies, connected with the bridge chip, and developed some modules as a reference design. So I'm going to take today's presentation on those reference designs. Before I start my presentation, I wanted to give you also a message from Toshiba Japan. So,
here at the Kawasaki System LSI Development Center, System LSI related research and development take places. Bridge chip is a key essential device to establish connecting among modules within the other architecture. As the world's leading semiconductor vendor, Toshiba has the honor to provide this bridge chip for Project ARA. But this is just the beginning, and we would provide a range of our technology to support the growth of Project ARA. For instance, we achieved the 900 frames per second super slow image capture technology. This is a result of long-term research that we have been conducting for camera sensor and processor. We have developed other camera modules that utilize this technology. It is in prototype phase right now, and we are planning for release of 5 mega, 13 mega, and inner camera modules. We will also provide developed environment for easy adjustment and tuning of camera images. Our presence in Project ARA would certainly not stop here. We are planning to provide varieties of modules, such as TransferJet, the Toshiba's near-field communication device, and health monitoring modules.
So let me tell you about Toshiba's reference designs. So we started this idea of development of the reference design in last year, 2014. We wanted to take some of the basic functions and connect with the bridge chip and develop a reference design. So the first, obviously, the basic function we chose was camera. And we are going to talk about that today. The phase 2 is this year. And this year, we want to take some of the other technologies, which is like wireless charger or TransferJet, NFC, or maybe external memories, and connect those into the module. And of course, phase 3, going forward, will be some unique technologies which we are going to use. We are planning to develop all module reference designs, all means different sizes, 1 by 1, 1 by 2, 2 by 2 module reference designs. So before I go into camera reference designs, I wanted to give you a little bit information about our image sensor technology. We have various range of image sensors which has CSI interface and 8 megapixel, 13 megapixel, 20 megapixel different cameras are available. Different products are there, different optical formats are there, different frame rates, and then they have features like bright mode or HDR type of technology. One of the important feature which in our image sensor which is used is a high frame rate per second. So we have image sensor with 240, 480, and 900 frames per second type of image sensors. So this is very important technology because you can use this technology and develop very slow motion videos using these cameras. So using all these technologies of image sensor, we develop 3 different modules. First module is 2-megapixel module. This is a receiver bar type of module. The second one is a 5-megapixel 2x1 module. And then third one is a 13-megapixel 2x1 module. So this picture here is a receiver bar module that goes on top of your phone. And it's a flat, complete flat design. It uses our 2-megapixel camera, and also it uses audio codec IC, and it uses our high-density surface mount technology. This is designed because it has a camera which has the lowest height, and it flushes with the display thickness, so it's a flat design. As here in the diagram, you can see that the bridge chip which we have developed is used, and then camera has CSI interface, and then it connects with the ISP, and then through the bridge chip. Bridge chip also has a standard interfaces like I2S and I2C, so audio IC is connected through that, and then some of the other devices which are in red are from Toshiba. So this receiver module is also available as a reference design. The next one is 5-megapixel, and this is where the excitement comes. So I want to show you first working ARA 5-megapixel camera module. And we are very thrilled and excited because this is the first ARA module. As you can see in my hand and in the picture, the front is looking like this. It's a camera module. The back side has a connection to an endoskeleton, and then inside you can see in the picture. We are very excited about this. And the next one, next camera module is 13-megapixel, which is, again, I can show you here. The 13-megapixel camera module, same thing, front end and back end. Thank you. So let me show you what I mean by working camera module. So this is a 5-megapixel camera module, which I showed you. And the video here shows how it works. So that's the development board. That's the inside of the camera module, which is connected to the development board. This is the top plate, which I showed you. It's connected. Now it's turned on. Camera is pointing up. So you see the top ceiling right now. And then the picture frame is brought in. And then you see that it's a working camera module. Thank you. So as I said, when we developed the reference module plan, phase 1 was a camera basic function, and we are done with that. The phase 2, which is starting this year, we want to develop new camera modules with the new features. One of the features is TransferJet. Well, there is wireless charger, TransferJet, NFC memory module, as it said. But TransferJet is a technology which is a close proximity technology, and it's a high-speed data transfer technology. So we plan to develop a reference module in this year using TransferJet technology. And in fact, I'm saying that we plan to develop this year. We are a little bit ahead of schedule. I have it in my hand, the TransferJet reference module also. And thank you, thank you. So we will soon make this type of reference designs available, and maybe later on I can describe more about TransferJet or other unique modules which we are thinking. So the next question is, how do you get access to these module reference designs and all that? So we have a Toshiba homepage, and on Toshiba homepage we have developed ARA project site, and users can go into this project site. It looks like this, and then when you go into the site, it has all the information about the bridge chip. It has all the technical data, information, specifications, all those things, as well as it has various solutions and module types, and then reference designs information will be available. So you can go into, for example, different application examples. It will show you how you can connect bridge chip with different technologies. and download all the information about the specifications, etc. And then there is also a question page where you can go and browse through frequently asked questions. And that concludes my presentation. Thank you.
So I'll talk about Marvell's involvement in the ARA project. We started with the ARA about 6 months ago when I met with Paul in London, and I was thinking this is a new project, and this is all about democratization of hardware, and we are in the business of generating a lot of hardware. But the more important thing, which I would like to reflect upon what Regina talked about today, is it's all about building a platform. And platform has a lot of things behind it. One of the most important thing is a platform means that it can create a most derivative solutions around it and new use cases behind it, as Anil said in the earlier part of it. If you look at Marvell started about 20 years ago, and we have come a long way and enabling several use cases today in the industry, starting from 3D printing, which we showed at CES to democratize 3D printing, connectivity solutions, networking infrastructure, cloud services, storage. We've been working with Google with Chromecast in the past, green energy, automotive, and IoT, as well as digital entertainment, and most importantly, the cellular handsets, which we are going to talk about as a starting with the ARA project today. So if you look at, to build a platform, you need a complete system solutions, and to build that kind of a platform with modular platform like Project ARA, it's actually part of our genesis to have all the key technologies enabled as part of the modules in the market. So having said that, if you look at what we did is we started with the most comprehensive and the best solutions available at that time for Project ARA. So one of the audience asked a question that how will the Project ARA handset will compete with the best in the handsets in the regular cellular world. So we took a 64-bit quad-core LTE SoC solution for Project ARA, working with Google, and you saw that as a part of the product evaluation boards today, which has over 1.5 gigahertz quad-core Cortex A53 CPU. It has LTE, best of the class LTE, globally certified LTE, which is very important. And more important is it is a multi-mode solution, which means that it can run in any network globally in the world. Of course, except one key technology. And then we have put in the best of the class GPU in there, which is a PSP class GPU, so you get the best graphics, and also forward-looking compatibility for the Android projects as well. And it can do over 60 frames per second, 1080p video, as well as the most important part is the security. I mean, we talked about exchanging modules, but it has to have the best security possibility as well. And on top of it, we want to make sure that it has a good evolution of working on the next generation platforms will require VoLTE, EMBMS, and so on and so forth. So we are not going to stop here, of course. We're going to move to the next generation of the products as well. But if you look at to enabling this technology, the most important part is to create a schematics and the complete module schematics, which will be available as part of the MDK, I believe in the next couple of weeks. So we have come up with the most affordable schematics as well as the modules. So we welcome all the module developers to start building these kind of schematics using this will be available for the MDK perspective. And we've worked with our close partner, Toshiba. We've been working in several different segments with them to integrate on the board with the Unipro chip, bridge chip. As I mentioned earlier, Marvell is a unique company which has the most comprehensive portfolio, so which allows to bring the most affordable access of such kind of handsets and the devices, and more important, the new use cases which we all have not even thought about today. So for that, we're bringing, as I mentioned, 64-bit application processors, which is already available today. Moving forward, the Wi-Fi solutions, multi-mode LTE solutions, GPS, NFC, Bluetooth, and of course, which are required, the PMIC and the RF. And RF is not easy for 4G, specifically when you start integrating as a part of the endoskeleton. Now, the one question was, how are we going to go forward and make sure this is one of the best processor or best phones in the world moving forward? So we're going to bring the 1936, a new octa-core platform, octa-core 64-bit platform, which will also be available for Project Ara, which also, of course, includes all the multi-mode technologies. As I mentioned to you, we are working with the key operators today to make sure EMBMS, which is the video delivery services, and of course, once we move beyond Puerto Rico and other operators, they'll be available, and also the VoLTE, and complete connectivity stack. One of the key aspects of this overall project is to make sure that the company like us have full open source commitments. So we have been working with the Android team for almost 8 years now. And we're going to work with Google to make sure that we are supporting the Ara developers globally and for the next stages of the project moving forward. So having said that, I think the most important, the next step is that from our perspective, that the application evaluation boards are available through Spiral 2 developer hardware in next coming weeks. And our continuous support is available from evaluation hardware plan for other connectivity solutions, as well as all the other solutions I mentioned earlier. And we have also set up a specific email which allows for any of the members here or the whole community to be able to ask any questions or support from Marvell. As I mentioned earlier, Marvell is one of the key companies which is which has the whole most comprehensive portfolio, and we're looking forward to supporting the whole module community. Thank you very much.
Hi, everyone. Good afternoon. This is Michael Wu. I run the Phison USA division here in San Jose. You know, I think we should give a round of applause for the great lunch, right? Right. Yeah. So, you know, Google is always good for a good lunch. But I do have one request. I do have one request that you will try to stay awake at least until the end of the session. Okay. So anyway, just give you some background about Phison. A lot of you don't know about what we do. So Phison is a leading NAND flash controller manufacturer and the application provider. Our product ranges from USB, SD, eMMC, PATA, SATA, and now we are moving on to PCIe. As you know, that NAND flash is a key enabler for all the mobile devices today. In fact, NAND flash is the fastest growing semiconductors today. So we are happy to be involved with the Project Era, which is a cutting edge cell phone. And we're trying to come up with a cutting edge storage solution for the Project Era, along with our partner, Kingston. So let me give you a brief introduction of who are the main developer company for this UFS module. So in 2010, Kingston, who is the top module developer in the industry, and Phison, we formed a JV to make a better solution for the mobile environment. So the product, including a wide range of eMMC, you got eMCP. Something that is really keeping all the mobile devices up and running. So for this particular module, our goal is to provide a SSD type of performance on an Era phone with Phison developed the controller IC and also design of the module, while Kingston manufactured the UFS package and the Project Era module that sits on the endo. So as a reminder, for the following slide, I'll be referring to a lot of UFS package. And on the left side picture, that's what I refer to a UFS package. And you will see how it will go onto a UFS module. So the reason why UFS is chosen over the existing eMMC user smartphone is simple: performance. So on the interface level, eMMC is actually top at 400 megabyte per second, but the new UFS Gear 3 two-lane actually provides an interface speed of 1.2 gigabyte per second. In addition, UFS also bring a full duplex and also command queuing. So it's very good for multitasking operation system and also for a multi-core CPU. So here are some system-level performance that you see on the chart. On the top chart is sequential performance, and the bottom chart is the IOPS, stand for IO per second. So how that translates to user experience, when you have a better sequential performance, you get a faster transfer speed on the large file, and when you have a fast render performance, when you do a multitasking, you give you a very smooth user experience. As you can see from the picture, on the red bar, you see a clear advantage of a UFS, especially on the sequential read and random read. So this is one of the key reasons for the selection of the UFS. And moreover, UFS module actually run right on top of the UniPro switch. So it's a very natural fit. So here's a block diagram of a UFS module. Just like other major module, our storage module is just sit right on top of the UniPro switch through the M5 Spiral 2 interface. And you got the Phison controller 8310 that's powering up, which is the core of the UFS module, providing the main name management, wear leveling, error correction, and other algorithms, using the in-house M5 and also in-house UniPro IPs. So this is a high-speed UFS module and also a high-density UFS module. So some of you may wonder how much of a capacity this Era phone can bring in terms of a storage. So right now, we're capable of stacking 4 or 8 die into a UFS module. So translate that to gigabyte per second, as most of you are more familiar, it would be 64 to 128 gigabyte based on today's NAND process node. And when we move to the next generation NAND process node, it's capable of supporting up to 256 gigabyte. And if you notice that because UFS is directly UniPro supported, so there's not required to have any bridge in between. So let's look at the form factor. So form factor-wise, our idea is conservatively, this module should fit into a 1x2 module. Kingston would actually take the controller and the NAND die, package into a UFS package, as you see on the black area, into a 11.5 by 13, which is actually a standard package for today's eMMC that powers majority of the smartphone today. So the package will be mounted on the PCB, and you also see some components surrounding. We've got a Krisko that's providing the reference clock for the module, and you also got the voltage regulator to provide the 3 different voltages that's required by the UFS interface. We're also evaluating the 1.1x1 UFS module, which of course is much better option. So the feasibility would depend on the actual layout. So having said that, again, let's kind of brief to you about the schedule of this, as Phison would provide the controller and Kingston is manufacturing the module. So the UFS controller is expected to be taped out in Q2 this year. And so with that in mind, we believe that the module, we should see some module, UFS module with the memory, with daughter board, with this whole thing by the end of the year. And we're gearing for the mass production Q1 next year. Again, very excited about being able to participate in this Google Era. We believe that this is one of the most exciting smartphone projects we've ever worked on, and it will be very exciting. Thank you very much.
Good afternoon. So, glad to be here. I thought I would be the only one from the Netherlands, but glad that Dave is here. I think he's one of the roots of this project, and I think that's really great to meet him here. And let's talk about one critical part of the whole module, actually, that is the display and the touch. It's actually the input and the output device of this project ARA. So I think this is really a great opportunity for Innolux to join this program. But who actually is Innolux? Actually, I think most of the end consumers, they don't know exactly what Innolux is. It is a company actually that normally delivers display and touch solutions to customers that are, for example, Motorola or Microsoft or whatever company. And basically, we are supplying displays to these kind of companies. And you can see on the screen several segments which Innolux is active in. We are a Taiwanese-based company, and we are active in, for example, TVs, in monitors, in medical industry, as well in automotive, mobile. And one of our latest products, I think is also nice to see, is also an Innolux inside, the Motor 360. So also here, we have done some great job to come into consumer products. But why would Innolux participate in this program? I think this is a very new area for us. So this new area, I think, can be very interesting for us because normally we have an R&D team that has great ideas and they like to express it. But usually we have to go through customers, they need to judge it, and there's a complex process basically to bring new technology to the market. And this actually gives a lot of failure because maybe 9 out of 10 new techniques are not coming to the market because our customers cannot handle it or they don't like it. So they already make a prejudgment for the end consumer to basically say, well, this is not something our customers like. But now in this program, actually, it's quite interesting to see that we can actually come with new technology that can go directly to the end consumer, and they can judge themselves. So for us, we also could be more entrepreneurship to our new technology and bring this to the market sooner. Next to that, I think also the future for our children, I think is also quite important to keep the waste as low as possible. And I think that's also one of our principles from our company, that we want to contribute to that as well. So I think that's also one of the key things, which I think is nice of this. You can upgrade your phone, you don't need to throw away the whole device, but I think you just can replace parts. And I think also from the display perspective, I think Innolux has several varieties of displays that can drop in later on. But what is now in the current solution? Actually, I have a small prototype, which is the future module as it's going to be in this project ARA. We are starting with a 4.5-inch screen. It's going to be a LTPS technology with IPS, which stands for wide viewing angles, so very excellent wide viewing angle properties as well. Very good efficiency, so that also contributes to the power consumption. And that's interesting, my text is disappearing. And what is also embedded is the touch, which is integrated into the display. We also have a cover lens on top of that, which is a Gorilla Glass, which is high protective glass. And we offer also quite high brightness. And this can be, of course, adjusted because there's also an ambient light sensor in it. But especially for outdoor readability, I think this is really excellent to use this kind of high brightness, so you can also read your emails or your internet outside. But also this glass is laminated to the display, so that also gives a very low surface reflectance. So also this contributes a lot to the outdoor readability. A little bit looking inside this module. I think that's difficult to see in this, but you see some buttons at the side that are supported for the volume up and down, as well the power button. And there's a frame around it, and inside the frame you have then on top of it the cover lens, the frame, the display, and there's a backlight unit with LEDs on the back side. And what you also see is then some additional components. Like I said, the buttons. There's a mic on the bottom side. As well, there are two sensors, according to the MDK spec, an ALS, as well a UV sensor. And there's a magnet to click it in the module. And of course, there's a big PCB as well inside the module that is used for the interfacing to the main board. So, to give you a summary of how this module will be and how big it will be. So the active area size you can see here, it's 55.5 times 98.5. And the outline, 76 times 120 times 4 millimeter. And it is, you can feel it later on. I can pass the module. It's a very light module. So I think that's quite convenient for the total device. I think Innolux recently joined this program. I think we are now having discussion in the last 3 months, and basically our plan is to execute this module. And looking at the schedule point of view, our plan is to start this quarter, and we expect that we have the first 50K samples available by June timeframe. That's our current estimation. And we expect to do 2 iteration steps in this time frame. So all in all, I think this is really something that comes close to our heart. We are a display company. We are also making touch. So I think this is really something that fits very well. Nevertheless, we are used to do business-to-business cases, and this new way, like in Project ARA, is giving also some challenges for us, especially in the logistics. As mentioned this morning, we need to ship out products piece by piece to consumers, and this is really a new area for us, and we will actually go together with Google and find the right partners to actually help us to come and solve this problem. I think that's something we are really looking into for help, and we're open for any suggestions. All in all, I think Innolux is very enthusiastic to support this program, and thank you very much for your attention.
Today I'm going to talk about some of the research that my group at UCSD performs, and the title of my talk today is an ARA biosensor for mobile health, or mHealth. So my group is called the Biosensors and Bioelectronics Group, and as you might imagine, we try to marry these somewhat disparate fields of biology and medicine with engineering. In particular, today I'm going to focus on one device, and that's a device that empowers me and you as end users to manage facets of our own healthcare. So, as a society, we've become more and more dependent on our phones for our everyday lives. We use our phones for more than just calling people. We use them to keep track of our calendar, take pictures, contacts, email, social media, navigation, and many, many other things. Okay? But we're seeing an interesting trend, and that's that our phones are becoming part of our healthcare. So doctors now can use video conferencing to talk with patients for virtual checkups. Our phone can keep track of our medical record and our vaccination history. Okay? And there's a whole host of these tracking sensors to monitor fitness and sleep and wellness. And in general, this is a trend that's known as mobile health, or mHealth. Okay? And this is definitely a start, but the future that I envision is maybe a little bit deeper than this. It's a future where our phones, our mobile phones, are our first line of defense in our healthcare. Okay? And I'm going to talk a little bit about that vision today. So if we take a look at these existing sensors, the problem is that they really don't take full advantage of this rich sample set that we have in terms of these biological samples, things like tears and sweat and, of course, blood. So we just need to think, how can we make these sensors measure these types of quantities, right? But before I tell you how we can do this, let's just take a second and imagine that we could. Let's pretend that we had this technology available today. What would we do with it? How would this be useful to us? And so there's endless applications of this, but I'm going to divide this up into kind of two paradigms here, one for developed countries and one for developing nations. And I think that developing nations actually probably present the biggest opportunity simply because there the mobile penetration of mobile phones far exceeds even basic infrastructure. So this is a tremendous opportunity for us here. So a couple of applications. The first one is obvious, the centralized lab. So if you go to the doctor today and get a blood sample, it takes a couple of days to get the test results back. You've gone home by then, hopefully. And that's kind of one data point. What if we could use this to, after the disease is diagnosed, to kind of track this over time, right? Do this daily, do this weekly. Obviously, this kind of technique would have implications for medical costs. Hopefully, it would help lower them. But in developing nations, this type of technique would be even more beneficial, where this type of a laboratory doesn't exist, and we're augmenting what's already there by bringing this close to the patient. So, of course, this would also be very useful for disaster response, disease outbreaks, and food and water safety are a universal concern for everyone. Okay? So I think that clearly there's a need for this type of technology. And in fact, there's already some precedent for a technology like this existing today. So diabetics currently measure their glucose level, and they manage their insulin in order to regulate their glucose. Okay? So the remaining question is, how do we bring this technology to the end user? How do we bring this to our phones? And a little bit of history here. Before we heard about the ARA project, we had already started working on this. We had already started working on this idea of how can we augment a phone, and really along the central theme of I want to use as much of the phone as possible. I want to reuse the screen. I want to reuse the battery. I want to use the wireless radios. I just want to augment this with the sensors that I need. That is, these medically relevant sensors. Okay? So we built one of these. It's a small biosensing module shown here. It's about 1 inch by 1.5 inches. And it plugs into the phone through the audio jack. Okay? The audio jack is an interesting port. It's universal across all smartphones or mobile phones, and that's why we chose it. But it presents a few engineering challenges, which is really good for graduate students. As a professor, I like that. That gives me something to do. And it interfaces with biology through these disposable test strips that are shown here, where we can customize these to particular diseases. And of course, we're going to reuse the phone for its data analysis, its storage, its informatics, and its kind of analytics capabilities. So one of the first things we did after we built this fairly low-cost device, it cost about $20 to build, was we wanted to see how this compared to the state-of-the-art instrumentation, right? So we took this device, this $20 device, and we compared it with a $10,000 instrument. And I don't know if you can see this, but they're virtually indistinguishable. Okay? So what this meant is that we don't necessarily have to compromise performance or sacrifice anything in order to have the mobility of taking this with us. Okay? So this is a very powerful message, and we're going to carry this forward with the ARA platform as well. Now, this wasn't without its challenges. Interfacing with a phone through the audio jack, we have very limited power that we can harvest from the phone. Second, the audio jack wasn't really meant to do this. It wasn't meant to send data to and from the phone in this fashion, so we had to play a few tricks. Okay? Lastly, the wide variety of phones that are out there today is mind-boggling. Okay? And when we started to characterize them, we started to see that the power available varied across all of these phones. Right? So this is the bad part about this work. The good part is that when we heard about the ARA module, this solved all of these problems. All of a sudden now we have this infrastructure where we can tap into the power, and we have plenty of power. We have more power than we had before, and we can use that to our advantage. Okay? We can leverage this additional power that we can now add capabilities to the device that weren't possible before. Okay? So we have additional versatility in the terms of the types of techniques that we can perform using this. And second, with this higher integration with the phone, we're able to reduce the form factor even further. So this device was already fairly small, but now we're targeting one of these 1x1 or 2x1 module sizes based on this tight integration with the phone. Okay. So just to recap, what we're trying to do is we're trying to develop the hardware to add this functionality to your phone to turn it into a mobile health biosensing platform, okay? For a wide variety of these mobile health type applications. And these tests that we can look at, they range from the influenza virus to infectious disease to all the way to heavy metals. Okay? And the key here is that this is a platform technology. That is that we can, by using these disposable test strips, we can target a wide variety of different diseases or other things to test for. So thank you.
First, allow me to introduce who Sunny is and what Sunny is moving forward. And Sunny is a public company in Hong Kong, and our headquarters is in China, Ningbo, near Shanghai. Maybe this guy here know Ningbo, but lots of guys know Shanghai, right? So as far as the partnership is concerned by Sunny, we established 2 R&D and marketing centers. One is Silicon Valley here, another is in Israel. Relying on this world's most innovative center, we establish and keep very good relationship with our partner. For example, such as the platform application company and some outstanding algorithm company, and also some key manufacturing companies. And also we have very good tier 1 consumer electronics customers. Right now, Sunny is ranked #1 of the automotive mounted business about lens set. And also Sunny ranked #3 of the in terms of camera module business of the world. Also, Sunny is very graced to be one part of Google's supply chain. Regarding to the product line, Sunny provide not only the optical components as a foundation, but also some different kind of camera modules. Consequently, not only the optical image system product, but also some interested end product device, such as Project Ayla, as our long-term goal. So let's have a look inside of the typically camera module, 5 mega AF autofocus camera module. After our research and simulation, we select Toshiba sensor and Sunny optical on lens and the RPS actuators. Why we make this combination? The purpose is we can make a very high efficiency tuning and seamless integration. And also we can keep very reliable quality control and a very stable product shipment. And also this combination bring the end user very cost performance effective. So as a optical imaging system expert, So what can Sunny do for next for Ella project? So here, just to show a video for every guy here. Today, the camera module has lots of different options. So we make multiple options for Ella project for next. First thing is the big aperture. So the big aperture can make camera collect more light energy and enhance the beta blue background performance, and as good as a professional digital camera. So the next thing is the OIS, optical image stabilization. So we already have a very mature OIS camera module. You know, OIS camera module can make, if you want to capture a long distance image, obviously the OIS module is perfect than the regular one. And also to help you to make a very good image performance at a low light. So the third thing is the dual camera. The dual camera helps you get very perfect high dynamic range and a very high sensitivity at a low light, and also help you get the depth information, and also help you make the camera module thinner. And you can do lots of functions such as background removing and refocusing after capture. Additionally, if you want make a different optical design for dual camera, if you make a new design, one camera is wide view angle, another camera is narrow angle, and after deal with a specific algorithm, you can achieve optical zoom performance. And today, the camera module's primary function just like make a good performance image capture. But I think the camera major function is changed. We can digit out some senior function about camera. So the camera can help you. The dual camera can help you find out more surrounding information, help you collect the data surrounding you, and help you to measurement the object, and help you to do lots of analysis surrounding you. So if we expand the baseline of the dual camera, it can help you make very high accuracy 3D information. And also, you can get a large range of depth of the information. Based on this hardware technology, you can develop lots of funny and interested apps, such as stitching solid facing image, and help you choose the cosmetics, and help you change your file style. Yeah. So I think in the future, the camera can bring you more funny. So why Sunny? Sunny has a very good optical design experience. We can make a customized design, whatever you want. And we also have very good software development capability. And we have very mature camera module design. And we can do lots of different simulation and analysis in the design early stage to avoid some failure issues at an early age. And also, we have our own automatic machine development equipped with our in-house development automatic machine. Sunny can expand our capacity very flexible. And so Sunny can guarantee very big volume for Project Ella. So there is an old saying in China. Today, old guy just facing a new problem. because after Ella project is very popular, the business model will be changed from B2B to B2C. But Sunny will enjoy this challenge, just struggle with Google and win together with our all partners here. Thank you.
200 million people have undiagnosed diabetes. 800 million people have no access to sanitized water. In this century, right now. Why? I mean, we literally live in the future where technology is transforming our lives. Flying here, I was able to choose my movie on my device wirelessly on the plane. Incredible. However, the majority of population is still facing basic health and environmental issues. We at Vestigen want to help bridge these realities, which is not easy. Along the technological challenges that has to be overcome, the right team that has to be set up, you are forced by economical convenience, return on investment, market fit. But we believe in people. We believe in entrepreneurship. We believe in the possibility to change the status quo. And we believe in cooperation. Now, let me show you a vision how the ARA phone could help people like you and me and people around the globe already this year.
Maya's Field, Teanga's Well, Anel's Hospital. They need neither higher camera resolution nor a better Wi-Fi connection. However, their lives remind us of the real purpose of technological progress: improving lives. Help, hope, and substance. That's what Life Compass is all about. A phone that can feel and see your health in a tiny drop. A phone able to sense the water you drink, the soil you rake, or the blood you feel in your veins. Always, wherever you are, and whenever you want. Because it's not the circumstance that should decide about quality of your life. It's you. Vestigen. Navigate life.
This thinking is beyond the current trend of just a new phone with a better Bluetooth or Wi-Fi. Just imagine that this can be done also with a feature phone, a simple feature phone that can provide basic diagnostics. We started with a goal. We wanted to help people with kidney disease. We focused on several groups and found out that 30% of diabetic patients are developing kidney problems. That was our lead. So we started. And after 7 months, we were not only able to detect molecules in blood, but also in water, and had promising results in soil and saliva as well. A platform was born, a platform that is able to detect molecules in liquids. We call it the liquid tricorder. Then we met the ARA team and saw great opportunities in collaboration. Our goal is to ship a phone, a platform that enables people to test liquids, such as blood and water, to prevent disease. This can be done already this year. The technology is already here. Smaller, affordable sensing. Our platform works similar like a glucometer. Electrochemistry is the basis. You take a disposable strip and you put it into the device. You take a sample of blood, put on the disposable strip, and the device is measuring current resulting from the chemical reaction on the disposable strip. The peak current depends on the concentration of glucose in blood. This is our functional prototype. It consists of several parts. This is the analog part. This is the most important part. This is the part that is able to detect molecules in liquid. Then there are other parts, like Bluetooth, Wi-Fi, battery. But these parts can be also able to be a part of a phone. We are able to take this analog part and put it into ARA. So you can have your liquid tricorder always with you. Now let me show you two modules of the liquid tricorder. The electronics is the same. It could be also one module, but for better explanation. You have a blue one for water and red one for blood. You take a disposable strip, put it into the module. You take a sample of blood or water, put it on the disposable strip, and the phone is testing the molecules in liquids and is showing the results. But there is more. You can teach your phone new molecular tests. Imagine now receiving a package with new test strips for heart disease. You can start to check your conditions on the spot because the app is already upgraded from the cloud. Major steps have already been done. We have the electronics. We have the chemistry. We have the test strips. And don't forget about the data you could get. You can use them in research for public health, for precision agriculture, for water management. This is the opportunity for all of us to make diagnostics mainstream. So how can you help? The engineers are already developing the endoskeletons. It's great that there are 3 sizes of the endoskeletons, also the feature phone size. We are able to put the liquid tricorder into the ARA. Developers and businesses can improve this platform by producing new, novel, affordable test strips, like for tests for heart disease or liver. Together, we can bring diagnostics to the hands of those who really need it. At the end, I would like to thank you again, Paul and Anil, for the ability to be here today. I would also like to thank my team, friends and family back home in Slovakia. And I would also like to thank people from around the globe who are sending us support right now. We really appreciate it. Thank you very much.
I have a few questions. Maybe I'll start and I'll open the questions for the floor. Maybe I'll start with randomly, maybe with Phison. I was very interested in your storage module, and I was thinking the one by one was very interesting. I was curious, what kind of capacity is feasible, and in terms of challenges, what do you see the biggest challenge for having a UFS module?
Well, the design of a UFS module using the UFS package is actually quite straightforward. As you see that there's, we just take a standard packaging part, which is very standard today in all your smartphone today, and we put it on the daughter board. But there is some challenges trying to fit additional components other than the UFS package, because there was some additional reference clock, there was some, additional voltages that wasn't supplied by the DC, but it's required for UFS. But other than that, it's quite straightforward design.
Okay, thank you, Michael. Maybe I'll have a question for Shardul. You've shown a lot of variety of camera modules. We're curious, how easy or how tough was to make the first camera module working? Not only making, but also making it working. Can you comment about it, please?
Well, I think the simple answer is easy.
That's great for all the developers, who want to make modules.
So let me give you detail. I think, like I said in my presentation, the bridge IC, which is what we are making, and then of course image sensor product line, which I showed. So the first component, which is a bridge IC, has to work, and then image sensor has to work. So the reason I'm saying it easy, because we have all the image sensor which are already proven, they are out in the market, this kind of technology is available, and then the bridge IC, which we are working for all the module developer. We wanted to, once it reached to certain level, we had to put those two components together and other components in the module together. It was, because both the components were working, it took about 2 months to put everything together and test it out and make it work on the development board.
Oh.
So 2 months is pretty good turnaround time for all the module developer. Bridge IC is available, and they have their own technology. So
that is very exciting.
That's why I'm saying it's.
Yeah. Thank you. That's very exciting. So we can expect to see some new modules to come up in 2 months.
Yes, we are very much encouraged for all of you to develop more modules using Bridge IC.
Awesome. Thank you. Maybe along the lines, maybe I'll have a question for Vivek from Marvell. I'm curious, what is Marvell's vision for a solution set for a modular phone like ARA? Can you comment about that, please?
As I mentioned also as a part of my presentation, that to build a modular phone like ARA, you need to have multiple different technologies which can actually come together. And I don't think so it's only about a phone. I think it's also about all the other derivative use cases which can be brought up using this, including Internet of Things, which we are very bullish about, as well as all the other technologies, as well as the markets like automotive and so on and so forth. So our vision is much more beyond the building a phone, but also to build the modules for all different parts of market segments.
Awesome. Thank you. While you're there, maybe can you pass it to Innolux? So thank you, Fred. You're a display expert. Irrespective of Innolux, I'm curious, right? What do you see? What possibilities could happen on given ARA as a modular platform? What do you see the roadmap as an expert?
Yeah, excellent question. I think there are many possibilities. When I look at the display and touch, basically it's an input device and an output device. And basically you as a user can see it. And actually by seeing it, there are many things we can do as Innolux to basically come with new techniques that we can offer, which can come quickly to the market. Some examples we have, for example, is in the past we developed 3D display. There are techniques that we can basically implement nowadays already to offer you a 3D display if you are interested. Also from the touch point of view, actually 3D touch could be also another area where we could offer some additional value to the module. So also in that segment, I think there are some possibilities. But look, for example, now we are talking about a 4.5-inch HD, but we could also upgrade to higher resolution. Nowadays, I think Full HD is also already available. And you could also go for high gamut, to get more color, more saturated colors. Thinner module, more narrow border. Yeah, I think there's endless possibilities to basically come up with new things, and that can go quickly to the market, basically, if that is going to happen.
So, maybe along the lines, right? What makes ARA unique, right? Some of those technologies probably could come to any other smartphone, right? Being modular, does it help, or is there anything that you could do only on ARA, which probably not feasible on the regular smartphone?
For us as Innolux, I think it could be quite interesting to actually test new technologies in the market. Normally, we have to go via regular channels, and we have to first convince and maybe also get others' opinion, and it takes a long process. But maybe now it can be a much quicker process, and the number of iterations will be much quicker to the market. And that can bring also more enthusiasm for our engineering crew to come with new techniques to the market.
Awesome. Thank you. Next, I have a question for Sunny, David Wang. You showed us a lot of options. A camera, 3x optical zoom, and 360 degrees zoom and everything. I was thinking, right? Correct me if I'm wrong. A lot of those functionalities are not available on the existing smartphones today, right? So correct me if I'm wrong. And I'm curious, right? How challenging, how tough is it to bring all of them together into one single module? And you showed us 1 by 2. Can you explain us, the challenges that are in putting all of them together?
Okay, so actually, for the dual camera, the very challenging thing is you should keep the axis direction at the exactly same directions, and so that needs very high tolerance accuracy control. So you should keep the very good tilter control, very good decenter control. So Sunny has our own AA machine, active alignment machine development. So we can solve this problem very well. And also for maybe another thing, so maybe the end user will be concerned. Is there any problem about the size of the dual camera? But I think it's no problem. Yeah, today some tier 1 brand already integrate the dual camera in their product.
Okay.
Yeah.
Okay. Thank you. And the next question I have for Drew Hall. Drew, just curious, what is your vision of Ara's play in the mobile health market? What solutions do you see coming on Ara platform, or what is feasible?
Yeah, sure. So I think that there's a lot of opportunity here to make different biosensing modules for the Ara phone. We talked about one today, but we're interested in my research group, and I'm sure many others, in a lot of other biosensing modules or mobile health modules. So I think that there is a huge opportunity here. And it's because the phone it's a very powerful computer that has all these wireless radios and everything connected. So I think that its expansion into the healthcare market and this mobile health, it's a very natural fit.
Thank you. With that, we'll open the question for the audience on the floor, please. Go ahead.
Yeah, hi. I'm Joseph. I have some question about the biosensor, because I make the 2x2 glucose meter prototype. But, making medical devices is not that, really it's not that hard like as before. But the problem for now is more like how to get a FDA approval and even safety issue, and then some other there's a more obstacle for all the certificate and then kind of safety, and figure out how let doctors use that devices by insurance code, and then there's so many things behind that. So not making module and then just putting on, it's not that's the first step, but to make that make that module to everyone, we have to go through those kind of procedure to figure out the problem. So how do you think about that future plan to figure out all the behind the complications?
Sure. So you made a lot of great points. The first one I'll say is that making these is not necessarily very easy.
Not very easy, yeah, that's right. But easy to make it, like I made it.
I would say you're right in the sense that the easiest part is making the module, right? But there's a lot of hurdles past that. And so partly in my talk, you saw that we split this up into developed countries that have a lot of regulations, the FDA and these, and developing countries where they don't have these regulations that are in place. And that's actually, again, where I think the bigger opportunities are initially, is in these developing countries where we can really bring to them medical infrastructure that doesn't exist today. But you're absolutely right. The FDA hurdles are tremendous.
Yeah, so when you just, pass the FDA, it's just, you can do almost every country. So it's just like easy to go with it. But that procedure is kind of pretty hard to go through. That's why.
But there's also some applications that don't require FDA approval too, right? Non-medical applications. For example, water testing is a very simple one. But you're right. The FDA clearance is very, very tricky. Good point.
Okay, thanks.
Thanks for doing the panel. This one's directed towards Fred Von Rees from Innolux. Has your company thought about making the low-end spectrum of a screen? And I guess this question's for everyone, if they're willing to answer it. So the low end? Yeah.
I think basically we, as Innolux, we can provide from the low to the high end. So we have all technologies in-house. Basically, currently for the pilot program, we will start with this solution, I think. But after that, there can be endless possibilities.
Cool. All right. Thank you.
Hi. I was actually wondering also along the lines of like display modules, if Google has considered partnering with an e-ink company to create an e-ink display module.
Excellent question. Actually, Innolux already is partnering up.
Oh, okay. Cool.
Oh, nice.
Oh, okay.
He directed that question to me, but thanks for answering.
When you have seen this latest Yotta phone.
Yeah, that's what I was thinking.
And
it's coming out.
There you go.
The back pane of that phone is from Innolux.
Oh, okay. All right. Cool. Thank you very much.
Possible.
I had a question about the biosensors. How big do you think the module for that would be? Can you make it a 1x1, or what's how small could you make it?
So that depends on how good my graduate students are, to put it simply. No, I think that a 1x1 or a 1x2 is certainly possible. We're trying to get it down to a 1x1, but at some point, we don't have, being in an academic setting, some of the high-density manufacturing techniques that, or even the army of people that a lot of my colleagues up here do. So we're a little bit constrained in that regard.
I just wanted to ask, the UniPro platform is an amazing thing, but I was wondering, are there any ways to reduce the power overhead that it necessarily provides as well?
I mean, for the power overhead, there are multiple ways to do it. Like, for example, there's a DVFS system, for example, to dynamically reduce the power in the processor. But when you have I would say, a distributed system like ARA, you have to actually control that power across the board. I think that would be something which would be for Paul or Anil to comment on, and how they plan to do that from that perspective.
Okay. So we'll have ARA or someone, you can approach them for a discussion on the topic.
Okay.
Okay, thanks. Maybe along that lines, right? I was curious in maybe Phison. I was thinking Phison, right? You're going to use UFS. You mentioned about UFS module, right? Which I was curious. How is the power consumption? It's a higher speed, and is it more power, or how does it compare with earlier solutions?
Well, obviously, for all the storage device, when you get to higher speed, the peak power is always a concern. But in our estimation, the overall power consumption bring by UFS module versus an eMMC, that's kind of a popular storage option today, it actually saves power. And the reason for that is that because it can finish the task quicker, so the total average power actually is lower because we can get into the standby power mode quicker that way. So we've seen that with the transition to a higher cutting-edge storage module, there's not much impact for the power consumption.
Okay. So maybe, of course, I'll defer to Ara and Seth to comment about it, but, in general, would you say that, along with UniPro, being a modular architecture, you can bring latest and greatest technology, and probably, that which is, which will go along the roadmap of, reduced power consumption, whereas increased functionality, right? That could help. Those are the features that come up in ARA, right? Okay. I think we are running out of time.
Can I get one?
Sorry, yes, please.
Can I get one? This is for, I guess, Innolux and UCSD. When we're looking at biosensors, the basic medium endo, which is the launch release, we thought was insufficient for what we were trying to do for patients and providers. So we looked over the horizon to the HKL parceling, which requires the smaller real estate of the screen and gives you a larger module real estate on the front. So any of you guys looking at the parceling configurations beyond medium endo? Because we are.
So I can say that we're not. We're fairly focused, and Anil's kind of helped us steer towards being that route.
I think not much more to contribute. Basically, first it's important to get the pilot done. And I think going through the pilot phase, after that, I think you will see more possibilities. But first thing is, first step is the pilot phase.
Thank you. With that, I think I really thank our panel. Thanks a lot. Thank you, everyone. Okay, maybe before that, maybe I'll have a few questions for the panel. Maybe I'll start with Shardul. So, it was exciting to see camera reference modules from Toshiba. So, I was curious, right? I asked you, I think, again, how easy was it to make your first camera module and make it working?
Yeah, so like I showed you, a working camera module, and the whole purpose of bridge chip is to make this process of development of module easier. So two things are required to make the module, at least in our case, in the camera module. One is, of course, the bridge chip, and the second one is the technology which you want to put in the module. So in our case, that technology was camera sensor. And we have image sensor, like I showed you, many wide range of products are there. So those products are already available, tested, and working. And then bridge chip, which we are developing, was reached to a certain level. So then it was just a question of putting bridge chip and the camera module together and test out the circuit and all that. So generally, the process is very simple. If you have bridge chip and if your technology is already proven, then it is very simple. In our case, it took approximately 2 months to put those two together and test it out and make it work. So that's what generally the process is. I think the key thing is the technology which module developers are bringing, how solid that technology is, and then connection to the bridge chip.
Awesome, thank you. I have one quick question for all the panel, and I'll open to the audience maybe. Maybe next to the Vivek from Marvell, I was thinking, and how does the modular phone fit into the whole Marvell's vision of how mobile communications will be moving forward?
Good question. So I think if you look at, as I mentioned in my presentation also, I think the modular phone inside Marvell, we're also working on actually technologies to make it more modular so that we can target multiple use cases and multiple segments as well. And the modular phone itself is actually, for us, is a great attempt for us to be able to work to create something new possibilities which we have not even dreamed of. Because if you look at today, the phone which is coming in as more of a monolithic in the markets, so users and customers and OEMs and everybody does not have a way to be able to customize too much. They're all looking at the similar kind of handsets. As our friend talked about the diabetes module, for example, detecting diabetes module, these things cannot be done in today's phone. So in our vision, we think that the world is going to be totally different in the next few years, and we need to embrace that. And we are bringing new technologies in there, which are more modular and adaptive to the new lifestyles moving forward.
Thank you, Vivek. Next, I have a question for Horace from Phison. You showed us really awesome storage module concepts that you're working on with Kingston. Curious, what are the biggest challenges in developing a storage module?
I think the module itself is not that difficult. I think the hardest part is the controller. Okay. Once the controller is ready, we are just Kingston can just take it into a package and then do the module. But another challenge is fitting it into the one by one. That's going to be the challenge. So we'll try our best to reduce the number of passives. But that also is quite related to the controller design, and we'll do our best.
Thank you. Mr. Meng, I hope you're not nervous anymore. Yes. So irrespective of Innolux, right, as a display expert and a guy from display industry for a while, what new innovative roadmap do you see for display technologies for ARA?
Actually, like some audience, question about if you put two camera module And if you can put that, and it will, I mean, come out like depths of the vision, and you could apply the 3D display, right? And the 3D you can come out. And actually, we have many new technologies under developing, like high color gamut. So the color saturation is very high, very vivid. And actually, we have a narrow border and thinner border, and other new technology is developing. So actually, once we know, I mean, the customer or the end user has the request, and we could feel the need. Yeah.
Awesome.
So that's what we do.
Okay, thank you.
Thank you.
And maybe one last question for my questions for
Okay.
Alex. Being a startup and a very young startup, right? What is your experience, or what are your challenges you feel in participating in the RI ecosystem?
Oh, it's a very challenging thing, but what is really necessary for me to say, I think what counts is the problem and the idea. And if the problem is really important, so many things can be solved because you take the right people then around it. So I think this is the main thing about it, to find a really great problem, to round great team around it. So that's my...
Okay, thank you. So the panel is open for audience, and I believe we have a question from Singapore. Please go ahead.
Hi, Mr. Shardul. I had a question regarding the flash. Is the flash integrated, or are you all thinking to integrate the flash in the 5 megapixel and the 13 megapixel modules?
Yeah, right now, you mean camera flash you're talking about? No, the module which we have is not integrated with the flash. We are showing only our image sensor capability. So, and these are all reference designs. So these are not like regular modules. We are going to make it available. So we hope that people who are going to use our reference design will integrate more features in this reference design. The one which I showed you does not come with the flash. It's just image sensor.
And one for Mr. Ming in Innolux. Hi.
Thank you. Yeah.
So in the current display technology, does it use like a backlit type of a sensor, or which technology does it use in the current display?
Sensor?
Display technology.
Display technology.
Which technology does it use?
Now is I mean should be the same. I mean as the mobile phone LTPS or amorphous silicon to make the with IPS technology to make
IPS technology,
yeah,
right?
IPS.
So I guess it does require like it does not use AMOLED or Super AMOLED or something of that sort.
Yeah, I mean AMOLED is under developing, but actually we need to make some I mean.
Progress in that.
Yeah. So now the popular or the mature technology is LTPS and amorphous with IPS. Yes.
So it has a backlit display. It does not have a inbuilt light system. Like IPS works on a backlit display. Backlit, there's a light behind.
Oh yeah. We still need the backlight. Yeah.
You need the backlight.
Yeah.
So that would be having constraints on the battery. Like the battery consumption increases.
Yes.
Does it affect the battery?
Yeah. Yes.
That's it. Thank you.
Okay, thank you. We have a question from Bangalore. Bangalore, please go ahead.
Hi. This is a question for Alexander Vestigen. Very nice module. Just wanted to know, I'm coming from the pharma side. So now if we have the chemistry, can you help with the analog and the electronics part? Perhaps the chemistry could yield electrical or optical kind of output. Do you do that?
Okay, this is a quite technical question, but we are open to answer it. So I would further give it to my colleagues.
Okay, thank you.
If it is okay for you.
No problem, thank you.
Okay, thanks.
Okay, before we go to Singapore, can we go to Taipei, please? Taipei, please, go ahead.
Made a very important chip
IC between the module and the end of the bridge IC. But as a module maker, we don't have the knowledge to the bridge IC. How do we do with the firmware? We know you build many modules like camera, NFC. So can you recommend us how we do with the firmware? Should we rely on Toshiba-san or some other software third party to deal with that firmware modification to accommodate our design?
Yeah, so for the answer I can give you in two parts. One is there is after this panel, there is a second panel where we are going to describe, Toshiba person will be here, and he will describe more details of the bridge chip and AP bridge, and that will give you more information. But let me tell you that what we are going to do is a bridge chip will be drivers for the bridge chip will be available, and the firmware will be available from Toshiba, and then we are going to release it on our website. So you will be able to get that information, and then when you make a module, when you have the other technology like camera or NFC or Wi-Fi, of course you need device drivers for those, which will be module developers' responsibility, or if you're using Toshiba parts, of course that will also come with it. But the bridge chip software, the basic software will be available.
Thank you. Please go ahead from Singapore.
Yeah, hi. This is mainly a question for Mr. Vivek. In terms of processors, there's a lot of players in the game, and NVIDIA has announced that they're one of the module developers for Aura. So in terms of processing capabilities, what does Marvell offer versus the competition?
I can only say that best of the class. And also, it has an option to do integrated as well as the applications, standalone as well. On top of it, application processor is very complex, as you understand. It's also driven by, we also provide multiple islands for power in there, power domain profiles, best of the class video graphics integrations, GPUs integrations, and so on and so forth. We have been powering, if you look at, you talked about certain companies which they have divested themselves from the modem technology. It's not an easy thing to do. And we are still plowing ahead to make sure that that's available for the global markets in competitive fashion.
Okay, thank you.
Thank you. Any questions from audience? Maybe I have a question for, sorry, go ahead.
So as of now, this seems to be more of developing countries, so for healthcare. So if you bring back to developed countries whereby they have very strict personal data protection laws, how would you see or envision Vestigen moving forward in this field?
Right now, we are not in the situation that we are going to store the data. So this is the first answer I can give right now. So this is how we handle it right now. But furthermore, there are possibilities, but it depends only to make it and done.
Okay,
so
thank you. Thanks.
Okay, any questions? I have a question for Phison. I was looking at your storage presentation, and I was like thinking UFS, right? You talked about UFS. Can you comment about what is the power consumptions and what are the challenges with UFS?
Okay, I think in the standby or in the suspend mode, UFS is comparable to eMMC, but if you are talking about active current, we believe UFS actually has a chance to do better because of the faster performances. So the average power over time could be better.
Okay, thank you.
Can I add to that?
Sure, please.
So Toshiba also has a lot of memory, right? We also have flash memory technology, eMMC and UFS. So I think answer is right. The difference between eMMC and UFS is there. Today, UFS has posing another challenge because UFS is point-to-point connection right now, and it is not a network way. The data is not working. So in Aura phone, it's a network architecture.
Yes.
So in fact, Google and Toshiba are working together with the standards committee to enhance UniPro so that it can support this network architecture also. Until that happens, there is another challenge because it is a point-to-point connection right now.
Thank you. Yeah, that's a very good point, right? I think, as Google, for Project Aura, we are inviting people to come up and collaborate with us in defining the standards and, how to make the architecture better. Thank you. Maybe sorry, there's a question from Singapore.
Hey, my name is Alexei. Question is about if we have the sensor technology, which we would like to integrate as a module for Aura, and we have the I2C interface coming out, basically to make a module, we just need a bridge and then mechanical enclosure, right, to make a module. So question is whether the bridge currently or shortly will be available as an integrated circuit. Is it going to be available as a IP block, so it could be integrated in the circuit design?
Yeah, so the bridge is going to be available as a chip. It is not available as an IP block. Bridge, so you will have use
any plans or?
We are not going to release that as an IP block.
Okay.
Because once you go into IP block, you really need UniPro IP.
Right.
And UniPro IP is available from IP providers. But of course, like I said in my presentation, that will make life complicated because UniPro IP is complicated, and then you need to understand all the protocols and complexity involved with the UniPro. And that's why we are taking that complexity away from you by making this chip. And a lot of things are built into the chip. So on one side, you have I2C or I2S type of standard interface. The other side is UniPro is generated from the bridge. So our plan is not to make that chip available as an IP.
Okay.
That chip will be available, and then you can just use that chip with your other technology and make it. And that is the one of the easiest way to make the module right now.
So you're providing samples already, or?
Yeah, we have samples, and that is what I showed in our modules. And currently, we have the bridge chip, which is available for Spiral 2 phones. And Spiral 3, like today morning, what you heard about Spiral 3 plans and all that. So we are going to make small changes to make it available for Spiral 3, and that will be available very soon.
All right.
And like I said earlier, there is another session where Toshiba will present more about bridge chip and AP bridge and all that. So you will be able to get more data on that.
Thank you.
So the next panel actually will talk more detail about actually how UniPro IP is available. So thank you. Maybe before I end, I have any other questions from Bangalore or Singapore? Thank you. Then let's end the panel. Thanks a lot.
Thank you.